Hi, hello everyone. So this is the video dealing with section 4.7, inverse trigonometric functions, and this is the third part, part 3, where we go over the inverse tangent function. So the notation, as we probably already know, tangent inverse minus 1 of x, and that doesn't mean tangent raised to a negative power, it's just a notation for tangent inverse. Now, tangent inverse is similar to sine inverse, where again we have to restrict the sine and the cosine and the tangent because otherwise they wouldn't be functions because they would fail the vertical line test. Now, for the tangent, we're going to restrict the domain the exact same way as we restricted the sine inverse. So it goes from negative pi over 2 or minus 90 degrees to pi over 2, 90 degrees. So the sine axis is the y-axis, the cosine is the x-axis, and tangent is right here. Okay, so it's kind of difficult to do a straight line on this thing. So this is the tangent axis. Okay, now it's not the same as the y because the y has a maximum of 1 and negative 1. The tangent can go to infinity. So for example, we already discussed this before. Let's say if you have this angle right here, whatever this angle is, maybe it looks like 45, but whatever it is, the sine value is this blue line. This is the sine. The cosine is this, whatever, magenta line. And tangent would be stretching the line until it hits the tangent. So the tangent would be this value in green. Okay, this whole thing right here. Now, if the angle is positive, it's above the x-axis. If it is negative, it is below the x-axis. Okay, so just like sine, if we have a negative value, all we have to do is just flip the angle found in the table from positive to negative. Okay, so this is pretty easy, just like sine. Let's take a look at these two examples. And, again, for the known angles, we have to know the table. Okay, but because we're going just from negative 90 degrees to 90 degrees, we only have to know these values. So how would we do tangent inverse square root of 3? So we go to tangent, we see where radical 3 is, and we pick the angle. 60. Okay. Imagine, so this is supposed to be minus. Imagine I have a negative tangent inverse minus radical 3. Okay. The table only shows the positive, so you go to the positive, you pick the angle, but because the value is negative, all you have to do is go below here, below, right? Because you're below, so here is, if it was positive, this would be 60 degrees. Okay, if this was positive, it would be 60 degrees because it's negative is negative 60. So all you have to write is negative 60. Okay, radical 3 over 3, but negative. So you go to where radical 3 over 3 is, you pick the angle, and because it's negative, minus 30 degrees. If it was positive, positive 30 degrees. Okay? Now try this one. See if you're able to do this. Tangent 0. So what would we do? Okay. You go to the table where tangent is, see if you find one of the known values, and pick the angle. And sure enough, at 0, so remember the axis for tangent is this one right here. So at this location, tangent is 0, just like the y coordinate is 0. So we picked the value. Now because tangent is this axis, this is the tangent axis, I can have some question like this: tangent inverse of 9,000, maybe 98,999, for example. Okay, if you do this, this is not one of the known angles, but we can do this on the calculator, and it's going to be very close to 90 degrees. It's not going to be 90 degrees. Maybe it's going to be 89 or 88, whatever, but it's going to be very high, and I'm going to show you why using this table right here. I'm going to pull it back a little bit. Okay. Again, here is the tangent axis. Now, as the angle is increasing, imagine you have this angle. Right now, imagine you have this angle. You see, in order to reach the axis, right, this is the value of the tangent. So as increase the value to close to 90 degrees, the tangent becomes incredibly large. But what happens if it is exactly equal to 90 degrees? Well, that's impossible because at 90 degrees, the line would be parallel to the tangent axis, right? At 90 degrees, I am right here. These two lines would not intersect. So tangent inverse of infinity would be 90 degrees. Any other value, it doesn't exist, right? So that's why we have at 90 degree, it's undefined because the two lines don't intersect. So obviously we cannot use infinity. So this is undefined. Okay, so for known angles, we have to use the table, which eventually has to be memorized for exams and the final. But what if I have, angles that are not known for either sine, cosine, or tangent? So those are probably the easiest questions because we don't have to remember, the restrictions or sine or cosine of the angles in the restricted domain. We just type them in the calculator. Okay, so for example, let's maybe do cosine inverse of, how about 0.378? I think I've used this number before, so let's do. So I have three questions: sine inverse of 1/4, tangent inverse of minus 9.65, and cosine of this. So these are not known angles, right? Like the ones we see here in the table. So for those, we'll use the calculator. So let's go to the calculator. So the way to do this is, as I said before, you pull up the function sine inverse and you type in the value that you're looking for, and the calculator will give you the final answer. Make sure that you know that you are in degrees or radians. So my calculator is um, uh, in degrees. So let's do this. So clear. So sine inverse, right? You can see sine, cosine, and tangent here. And the blue functions, you have to press the second. So sine inverse 0.25. And we get 14.47 approximately. So my calculator is in degrees, so approximately 14.47 degrees. So very easy. The calculator already takes care of the domain. How about tangent inverse minus 9.65? Same thing. You go to the calculator, pick the tangent inverse. So second tangent. Now for the minus in here, be careful not to use the operation minus. It's the one below the number 3. 9.65. And then we should see a negative angle. So the calculator already handles the negative domain. So minus 84.08. So approximately minus 84.08 degrees. And the cosine inverse of 0.378. And then I think we should do negative 0.378. Okay, so let's do both because cosine is the one that we have to adjust. We have to adjust. So cosine, just move this a little bit here. So let's pick second cosine, 0.378. And we find the angle 67.79, approximately 67.79. And let's do the minus now. So in the minus 0.378, I know that I'm in the second quadrant, right? And I know that I'm in the second quadrant, about 67 degrees above the 180 degrees. Okay, so I don't know if that makes sense to you. I could draw a picture, but let's see if we can do this. So minus 0.378. And then we get the 112.20. And this is what I wanted to show you. So 112.2. So approximately 112.2. Okay, now this is what I wanted to show you. So here's the unit circle. Here's cosine. Now this is the 67, approximately 67 degrees. It's not one of the angles that we know. So this distance here, not the one that I just drew, this one, this is the cosine of 67.79, which is 0.378. If I am talking about the negative, I am here. This angle is 67. Okay. And the distance that I'm interested is this minus 0.378. Now, how do I find this angle? Well, this angle is 180 minus the 67, approximately, right? So 67 or 68, and this is exactly my 112 or 112.2. So this is perfectly right. So the calculator for all of these questions, it already adjusts for your restricted domain. So you don't have to worry about that. So for all of these unknown angles, all we do, we use the inverse function on the calculator for either sine, cosine, or tangent. And we pick the value the calculator gives us. Okay. I guess we could try one more to see. Let's try one more. Let's try sine and see if the calculator is going to give us the negative. So we can even try one of these values from the table. But so this is easy because the calculator is not going to give the answer in radical form. It's going to give us the answer in decimal. So let's do sine inverse of minus 0.5. Okay, so on the sine, I know my sine is this axis. This is theta, and in case I have a positive 1/2, so sine of positive 1/2 is my 30 degrees. Now, I want to do minus 1/2 because I want to see if the calculator shows me negative 30 degrees or it's going to show me 330. Now, the answer we need is this, because the domain of sine inverse is from negative 90 to 90. This number is not in here. Okay, so we have to answer minus 30. So I'm not quite sure if the calculator is going to say 330 or 30, minus 30. So we are expecting minus 30. Let's see what the calculator does. So that way, when you take the exam, um, it will be okay. So second inverse minus 0.5. And let's see what we get. Perfect. So as I said before, as you can see, the calculator already adjusts for the restricted domain. So minus 30 degrees. So perfect. So for all of these unknown angles, positive or negative, you will just enter the value into the calculator and write the final answer. There's no work to be shown on these, and the calculator already adjusts for the positive or negative according to your restricted domain. So this is the last video dealing with the inverse trigonometric functions. Again, for the known angles, for whatever we're dealing with, sine, cosine, or tangent, we have to memorize the table, at least for the values on the restricted domain, and that could go from 0 to 90 degrees. Okay, so all of these values we have to spend some time knowing because they might appear on the exam or final exam. And for unknown angles, we'll use the calculator as you saw here.